I'm John Strack with Napholt, Senior PM. I work in Northwest Arkansas. We did a 200,000 square foot residence hall for the University of Arkansas out of mass timber. So this presentation will be about mass timber and about that project. If you got questions during it, don't stop. I mean, don't. It won't bother me if you stop me and you ask me questions. Okay, so just do your thing and ask them as they come up to you. What is mass timber? We talk about some codes, the pros and cons, and some case studies. The mass timber, there's a couple different types of it. We did CLT, which is cross-laminated timber, which is what you're used to seeing and like you'd see in old churches and older structures. And then NLT, which is nail laminated timber, which is exactly what it sounds like. It's 2x on its side. And those 2x are nailed basically in place, and it's more labor intensive. There's DLT, which is dowel laminated timber, and the dowels actually swell and they hold the 2xs, which are on their side, similar to NLT, in place. We use CLT, which is cross laminated timber, for our job in Northwest Arkansas. CLT could be used on a horizontal surface, which would be like your decks, or it could be used on the woods, and I guess it could be used on the vertical surfaces too, to create your elevator cores, to do your exterior walls, anything that you would want to use it for, it could be used for. There's a few others. The laminated strand lumber, laminated veneer lumber, and then timber concrete composites. The CLT is made, and they have finger joining to make them for like the splices on the long runs. Our panels were 4 foot by 40 foot long, and so they used the splicing method with the finger joints to create that length. Basically, it's what it sounds like. You're just taking a 2x material and you're turning one way and the next one the other, and then gluing them together, and through compression, that forms a very robust product. Some examples of some NLT, and then this is just some examples of some of the buildings that have been built, and you can see the finished product on your right. This is another example of the DLT, the dowel laminated timber, and these are predominantly used on the horizontal surfaces for the various heights, or the floors. It's not your conventional stick frame building with plywood. It most resembles your glue lam method. This is a glue lam with tongue groove decking, which was the older way that we did it and built these structures. And this is Cherie slides, but she would compare it back to putting together like some Lego blocks. It's almost like IKEA furniture, the way that it shows up. This picture is one of the building that we finished in Northwest Arkansas. There'll be some better pictures in a little bit, but what this gives you is an understanding of the vertical columns, horizontal beams, and then you have, this is a 5-ply, 7-inch thick cross-laminated timber deck. On top of that deck, we place a sound barrier, a sound mat, and then we poured 1.5 inches of gypcrete for acoustics to deaden the space. Mass timber's been used a long time. There's a really cool picture that I've looked for, but you know, working through the fire codes with fire marshals and such, we've seen some pictures of glue lams that are still standing in the steel structures that have failed because of the modulus of elasticity. There's buildings that have been around for a very long time that have been built out of wood, and it's coming, and it's here to stay. This is Oregon was one of the first states to incorporate mass timber. There's buildings over 6 stories. There's more buildings that are being planned. There's a 8-story, and then I want to say there's one that's actually going up to 16 stories that's soon to come into the United States. There's just more examples of some of the buildings that have been built in and around our areas. British Columbia and the northwest have a lot of softwoods that are being used because of the growth rate, and that's where the technology has started. More examples of some buildings, various codes, and the new codes that are coming out in the 2021 IBC will allow for different types and take into consideration mass timber. Benefits of mass timber are aesthetics and also the sustainability, offsetting carbon footprint. Sites are cleaner, less noisy, and at the end of the day, you have a very beautiful product that the structure actually creates a finished product. Cost, labor demand, speed of construction, they go up really quick. When we could start getting them stateside and local to our job sites, they'll go up a lot faster. I mentioned the sustainability feature. I'll go into that in a minute when I get to my slides. So these are all Cheries in the front end. The geographical issues are going away because of more plants are opening, including we're in the area of Walmart corporate headquarters, and they've announced plans for their new corporate headquarters that they're rolling out with several million feet of office space, and the opening of a plant to help provide mass timber to that project that'll open about 2 hours south of where we're at in Northwest Arkansas. I'm going through these pretty quick. I'm gonna go through some of hers fast, and then I'll get to mine at the end of this. But the concerns, manufacturing and transportation, that's going away. We're getting more and more plants. When I did this presentation back in November, there were some plants in the Northwest. There were some in the Northeast. We're located in the central part of the United States. We actually bought our mass timber from Austria, and it was shipped over. It was of the 200,000 square foot building. We had about a $5 million supply contract coming from Austria, and the next closest bid was 6, and it was located in Vancouver, British Columbia. But now, since even this November 10th through 13th presentation that we did, they've come online with a new manufacturing facility in Conway, Arkansas. That one, it will hopefully help drive the cost down and obviously make it easier to get it rather than shipping it from overseas or railing it in from the Northwest, which I think where y'all are at, if you're doing a project, makes sense to get it from Vancouver, British Columbia. But here we have a bunch of southern yellow pine. So Conway's got a new place. There's one in Birmingham, Alabama, and I've heard of one potentially starting up in Texas. Subcontracting was difficult as you're a pioneer, but we actually self-perform the erection, and the simplicity of it isn't quite known yet, but it's very simple to erect it. And right now we're considered the leading expert in it, which once I think people get a grasp of it, they'll realize that it's easier to erect than steel because you don't have all of the welded connections. It's just lags, screws, and then some protective measures that you put in place that we'll talk about in a little bit. Water performance is something you definitely got to be aware of and you got to protect. Fire performance, obviously wood will burn. There is they oversize the members in order to account for burn rates. So your 1 hour, 2 hour rated assemblies are taken into consideration. It's not only designed for structural, but it's designed for structural being able to sustain through a fire event. These are some of the summaries of codes. This is where my slides actually started up. This gives you a little bit about who we are as Nabholz, a little bit of our geographical area in which we work. You can see it's mostly in the central part of the United States. We have close to 1,300 employees. We've worked in quite a few cities over the last couple of years. We did close to $1 billion last year. A few years before that, we were at about 500 million, and we just continue to grow. Why wood? This is an example of a concrete building. This is an example of a concrete extraction. You got the production of concrete and the energy that takes. You got steel. You got the extraction of steel. You got the energy of steel and wood, right? So here's the harvesting of wood. Here's a couple years later after the wood started to regrow. So the production of wood is cleaner, and a lot of times these manufacturing facilities have gotten smart, and what they started to do is they're using the sawdust, and they're using the stuff that they can't use as kindling to produce energy for their manufacturing facilities. So it's almost like a net zero opportunity with this type of construction. That's why it's very enticing to owners. Not only that, but the biophilia, which is the like bringing the outdoors to inside to feel like you're a part of nature while you're working. Talks about production rates, health, wellness, and employee retention. So embodied energy, concrete's 5 times that of wood. Steel is 3 times that of wood, and then you have wood. So this is an example of some of the wood that we like, the forests that we have in North America and the United States specifically. You can see all the pine that we have in Arkansas, which is where the red dot, and so the attraction of wood to and the use of it for buildings and the generation of commerce, and backing up to the slides, the proper usage, of our land, right? That we can regrow and do it responsibly. So those are some of the enticing measures. Some other things that are benefits to it that aren't really seen here is that one thing is it's lighter, and so what you can do is you could drive the size of your foundations down. Right now, engineers aren't really doing that yet, but just like we would see a premium a few years back of maybe 6%, we're closer to 2% premium now to do a mass timber job, and we believe that within the next 2 years we'll be at zero or negative cost compared to a steel concrete building. It just takes time for people to understand what it is. It takes more competition with manufacturing facilities and more people that have erected it and installed it. So, and all that's coming. This is the building that we built, Adohi. It means from the woods. It's a Cherokee term. Like I said, it's a 200,000 square foot facility that was built at the U of A's campus. This gives you a little overview of it from a computer generated model. The uniqueness of this, when we started it, we gave a duration of time to the owner and said, hey, we can do it in this. But in here you can see when we were thinking that it was going to be all wood, but we had concrete shear walls. We have basements on these, and all of those impacted time and ultimately forced us to work a lot of hours to get this open by the start of school of 2019. Some risk assessment, and I had generated this presentation for people that were in the risk management profession, which is similar to what you guys do, but not completely. We did a CSIP with Workman's Comp, which I don't know if that means anything to y'all, but it's contractor controlled insurance program with Workman's Comp. We had the issues of procurement of mass timber, finding the skilled workforce, the modeling of the CLT penetrations. We'll talk more about that. Quality management systems that we put in place, protecting the timber from water damage, potential fire risk, and a very, very aggressive schedule. To start this thing off, we didn't know anything about it, so we took some field trips. We went out to Duke to look at some CLT. We went out to Portland to look at the First Tech building, which at the time was the largest mass timber job in the United States, and it mirrored what we were doing with glue laminated columns, glue laminated beams, and cross-laminated timber decks. It's very similar. We went out to Vancouver, and we looked at connection details and how this stuff went together. Backing up, we'll talk about this in a minute, but I want you all to remember this connection type, because we had a situation where we got shown another detail, and it ended up creating more workforce. So the thing with mass timber is that you have to model everything in its entirety before you can fabricate it. So any hole and every hole that's greater than 3 inches has to be designed into the model before you can fabricate the CLT. Not only is so it's for it's easier for them to do that in the shop, but secondly, the engineer needs to evaluate it and make sure that you're not turning that horizontal platform that people will be walking on with live load and dead load into a Swiss cheese that would ultimately fail. So those all have to be assessed on location for function and then for its structural integrity. Some things that we had to do, and you'll see, you can kind of see it in this model, is the holes had to be oversized. At the time that we started this, Hilti had not come out with anything in the United States for fire-rated penetrations through cross-laminated timber. So we helped them do this research and write the book on UL assemblies through cross-laminated timber. So we had to oversize the holes, say it 1.5 inches on each side or so, depending on what that assembly looked like. More examples of the model. And this is where I was telling you about oversizing holes, and you can see them a little better here. Procurement was a huge challenge, and I think that we've overcome that. Unless Binderholz can come in here and beat out stateside people now with the greater amounts of competition, then this is something that you may or may not have to worry about. But working with the cross-laminated timber manufacturer out of Austria, we had to come up with a good sequence, constant communication. We had truck drivers that actually started out on the East Coast, coming in through Savannah, Georgia, and the trucks would show up out of sequence. We wouldn't get what we needed. We were supposed to have this truck on this day. We'd get it on day 4. We'd get the day 4 truck on day 1. And so to take greater control of that, we routed them through Texas, actually Galveston, and they come up via rail after dropping in port up to Dallas, sit in a trucking hauler's yard, JB Hunt, which is a large trucking entity in Northwest Arkansas, and then they would bring to us from Dallas as we needed them. As they showed up, we had Holzpack on site, which is the representative for Binderholz stateside. They were on site helping us understand what we were doing, helping us figure out how to unload these trucks, stage it, assemble them in the yard, and then bring them across the street for installation. We used our robust quality management system to document the delivery of trucks, and we had separate crews. The way these things came in, instead of having that beautiful dove plate connection that you saw back there, sorry, went one too far. We had a knife plate connection, and since the knives were on the side of the columns, you couldn't ship with them, so we had to put them on in the laydown yard before we brought them over to the erection location. Show you some pictures of that in a minute too. When they came in the Connexes, and we just we had a flatbed truck that you'll see in this next slide, and we just pulled the pallets off out of the container and then put them on the back of that flatbed that remained in place for 6 months, and then we shook out the yard and finished our assembly. This picture gives you a nice overview of the project. Some of these columns span 3 stories. You can see the knife plates vaguely on the sides of these columns. I'll get you a better picture in a minute. One thing else that we point out is the red tape that you see at every spline joint in the CLT. When we visited some of the other buildings, and we noticed that they had water damage on their columns. So to overcome that, we came up with an idea we put caulking at the spline joint locations, and then installed the spline boards, and then taped those joints. That served for water on the surface, not allowing those to go through and stain the bottom side of the CLT, and also kept the gypcrete from seeping out. a gypcrete topping went on top of that. At all the columns, we taped them up with like a flex flash like you'd use around a window, a Trimco flex flash, to keep water from running down the face of those and staining them. And then the other thing you could see, a couple other things you can see in this photo, is you can see on the right, you can see the connection details that the knife plates that the beams would sit down on top of. When we saw these in a conceptual phase, there were no screw holes shown. And you can see in the photo now how many dadgum screws we had to install on each and every one of these in order to satisfy the design intent. So this was known when we received the final shop drawings. The final shop drawings came late because of CLT penetrations. We had to determine the architect didn't do that for us. We spent months and months and months doing that. And then the second thing is trying to figure out the connections. When you have concrete standards, ACI standards, you have steel standards, which the tolerances of concrete and steel are greater than that of wood. We had to come up with some way to overcome that, and it was a universal connection detail with knife plates. In hindsight, what it should have been is a knife plate from concrete to wood or wood to steel, but not wood to wood. We could have done the dovetail and made it a lot easier and shipped it and not had to have these connections done in the field. But I made the call after seeing them months late. Instead of going through a redesign process, we sent them to us and put all these on in the yard. Another thing you see here is the 3-story columns. This was done for ease of shipment, but definitely not for ease of installation. We had to battle getting the cross-laminated timber around the 3-story columns and into place. The crews probably wanted to shoot us at times for allowing this to happen, and it's not something that we would do again. Those are a couple lessons learned. So big takeaways from this, and I'll go to the next slide in a second, but big takeaways is modeling of the cross-laminated timber for all of your MEPF penetrations, making sure you understand that, making sure they're oversized for UL assemblies. Second thing is making sure you understand your connection details, and that you don't get the wool pulled over your eyes and then all of a sudden it's taken off and you have something with a crazy amount of screws. Making sure that you have water protection measures in place to protect the product, and then looking at your column heights, etc. So those are some big takeaways from this project. This is more geared towards the risk management that we did and the quality management inspections that we did for making sure we put the right screws with the right brackets, etc. And then this one gives you a little bit more detail on what I was talking about on the spline board, where we were caulking at the spline connections, which every panel at the edges is routed out to butt to the other panel next to it, and that's where that spline connection's placed. And before we place it, you can see our gentleman here, he's caulking it, and then after the spline board connection's installed, you can see the Stego tape that we put down, and then the ExoAir flex flash that we put around the columns to keep the water from running down it. And then the next one's just showing a slideshow or a quality management checklist for that. This is showing you what it looks like on the surface before we place the gypcrete. We've got actually on the perimeter of this, the initial design showed L angles that would house the gypcrete. Instead of that, we actually oversized the bottom track of the walls so that it would capture the gypcrete and keep it in. And then you can see in this picture all the fire rated assemblies that went in around the penetrations. You can see the tape around the columns, the tape on the joints, and then the sound mat that we helped put through various testing. It's different than the one that was specified. That's another story for another day. The hot works permits in place, and then this is actually this is an old time lapse, but I'll go ahead and run it for you. You can see when it started. June 26th of 2018 was the first column stood. and we got our substantial completion on August 9th of 2019. Let's see what's left here. What's this one? This is an old drone footage that we did. We've got a new one that I need to add to this, but it's kind of the finished product. That's so this site was located, that baseball field in the background is Fayetteville High School with about 5,000 or 6,000 students, and then the campus has about 25,000 students on it, and the basketball facility is on the left side of the screen, which is an 18,000 square foot facility. We had to keep our job open to allow for all of the, like, SEC network would come, and even the football games, everything's broadcasted through Bud Walton Arena. So they would come in, opposing teams would come in. We had to remain open on the back side of that throughout the entire process.